everyone, this is the SAT practice, quadratic functions and their graphs. What you should do is read the question, try to answer it, and then so push pause. And if you can't get it, then continue on. This group includes 3 problems. So go ahead and push pause and read it, because I'm not going to read it. And then we'll get started. Okay. So basically, when you're reading this question, a lot of the text is probably just providing the context of the question. So be sure to focus on what the question is asking. Here, to find t when x and y are equal. So that's what they're asking, to find t when x and y are equal. Okay, so getting to the answer, because both equations are given in terms of t, we have t here. In fact, we have both of these have 2t. What I'm going to do is solve for 2t. So basically, I know that x and y are equal, so basically I can say that negative 5t squared plus 2t plus 20 equals 2t. Okay, so basically negative 5t squared plus 20 equals 0 because the t's will cancel. So remember, x and y are equal. Okay, so 45 degrees. Now, let's go to the next slide. What we're going to do is do factoring. We can do, you can do it either way. You can do factoring, or we can do the square root method. So basically, if you do factoring, factor out a negative 5, and you get t squared minus 4 equals 0. Factor that more. So you get negative 5, t minus 2 times t plus 2 equals 0. So t equals 2 or t equals negative 2. Since time can't be negative, t has to equal 2. So the answer is B. If you just want to do square root method, what you would do is move the 20 over, so you get negative 5t squared equals negative 20. And when you divide by negative 5, you get t squared equals 4. So t equals plus or minus square root of 4. So t equals plus or minus 2. Again, t has to be positive, so t is 2. Okay? The next problem is the same kind of thing. It's a very lengthy problem. So read it and see what you can do with this. It's the same kind of thing. You need to interpret what's being asked. So here, to reach for the ground means that the height equals 0. So we know that height equals 0. Make sure you read this first. Alright? So your goal is to find the times. So solve for t. And then when h is 0. So this is our goal for the two projectiles, and find the difference. Then find the difference. We have to subtract them. And I also left some things out of this because I was getting, let's see, I left out that, I left out this. Let me write this. This is the initial velocity. And h subscript O equals the initial height. Okay, so make sure you read this. Here's your table. Here's your answers. Okay. So pause and read. Now, what we're going to do is, we know that both projectiles begin their respective surfaces and will be launched vertically at 40 miles per hour. So, right, we already know that the initial height is 0 and the initial velocity is 40 for both. So, according to the table, acceleration due to the gravity on Mars is 3.7 meters per second. All right, and the final equations for Mars, I'll do Mars like this, equals negative 1.852 squared plus 40t, because that's your velocity. So I'm just plugging in the formula. All right. Now, similarly, acceleration due to the gravity on the moon is, so I'm going to do moon now. The moon is 1.6, is it meters or miles? So, per second, which makes the equation for the moon, so height of the moon is negative 0.8t squared plus 40t, and that's just plugging in the formula. So substitute 0 for h and into each equation and solve for t, and then factor. So let me try to do this. I'm going to split it up. So I'll do Mars first. So for Mars, we have 0 equals negative 1.85t squared plus 40t. And we're going to factor out the t and get negative 1.85t plus 40. No, it's not a t. The t's gone. Oh, yeah, we have a t there. Okay. So when t is 0, we get negative, when this t is 0, and so let's look at this. We're going to set this to 0. So basically, we have this t equals 0. Now we're going to set this to 0. So you have negative 1.85t equals negative 40. So t equals 21.62. Okay, so that's for Mars. Now for Earth, no, for the moon, sorry. For the moon, at t equals 0, so we have 0. I'm just writing my equation. We're setting this to 0 equals negative 0.8t squared plus 40t. Factor out a t. Negative 0.8t plus 40. And so we set each piece, this t equals 0. And then set this to 0. And we're going to get negative 0.8t equals negative 40. So t equals 50. So at time equals 0, the objects have not yet been launched. So disregard this value at t. So we haven't even launched at this. So we're going to just cross out this part. We're just going to look at these two here. This one and this one. Now we have to subtract, and then we'll find the difference. So 50 minus 21.62 point equals 28.38 seconds. So that is choice B. If you had a calculator, you could also graph the equations in the graphing calculator and use the trace or 0 commands to determine when h is 0. Okay, we have one more. So basically, we said this one is more algebraic here. If x is negative 4, when x squared plus 2xr plus r squared is 0, then what is the value of r? So always look for a way to simplify the equation before plugging any numbers into it. The equation is a special product of binomials. So if you notice this, we're going to go ahead and write this as this. X plus r squared equals 0. Okay? Now substitute negative 4 in for x and solve for r by taking the square root of both sides. So basically I'm going to substitute in my negative 4. So we have negative 4 plus r squared equals 0. And I'm going to square root both sides, so I get r, and I'm going to rearrange those. R minus 4 equals 0, so r equals 4. This is a griddable, so you would just grid in 4. That would be your answer. Thank you and have a nice day. Bye-bye.